In this lecture, we will discuss about the operation of Nmos inverter circuit. So what is an inverter circuit? An inverter circuit is also known as a NOT gate, so which is a fundamental logic gate that simply inverts the input signal. That means if you give the input signal as low signal, that means which is having low voltage, that means 0, it will give the output as high voltage, that means logic 1. Similarly, if we provide the input signal as high voltage, it will provide the low voltage as the output. So here you could see the logic symbol of an inverter and also the truth table of an ideal inverter circuit. So here in this truth table you could see if we consider A as the input and B as the output. So if you give 0 as the input, it will provide us 1 as output. That means simply inversion of the input signal. Similarly, if we give 1 as input, it will give us 0 as the output. So here you could see the respective voltages with respect to input and the generated output. So when V in, that means input voltage is very much less, the output we are going to get is very much high, that is nothing but VDD, highest voltage possible. Similarly, when we give the input as highest voltage VDD, the output we will be getting is logic 0. And at the half of the, now let us discuss the construction of an Nmos inverter circuit. A simple Nmos inverter circuit can be constructed with the help of one Nmos transistor. So with the source connected to the ground as well as a load resistor that is connected from the drain to the positive power supply rail VDD. And the output is taken from the drain and the input is always applied at the gate terminal and it is applied between the gate as well as ground. The drawback of this kind of Nmos inverter circuit is, so while fabricating the resistors, these are not conveniently produced on the silicon substrate. That means even for small amounts of resistors, these occupy large area, so which is costly. So that is why we are going to construct the alternative circuit for Nmos inverter. Here we are going to use one more Nmos transistor as pull-up device. So here the alternative and more convenient way to solve this problem is to use depletion mode transistor as the load. So here the construction of Nmos inverter with the help of enhancement as well as depletion mode transistors is shown here. So here the enhancement device will act as non-ideal switch. That means whenever it is fed with complete low logic, it is completely open, and whenever it is fed with high voltage, it is completely turns on. And here the depletion mode transistor will act like a non-linear resistor. Here we need to consider few features while constructing this kind of Nmos inverter. So those are, for a depletion mode transistor, the gate is always connected to source. That means it should be completely turns on always. So in this configuration, the depletion mode device is known as pull-up device because it is going to pull the output to the highest voltage. That is why it is known as pull-up device. And the enhancement mode device is known as pull-down transistor. That means whenever it is turned on, so it is going to pull the output voltage to the 0. That's why it is known as pull-down transistor. And whenever there is no current drawn from the output, the current IDS is equal for both of the transistors. Now if you look at the Nmos inverter transfer characteristics, so these are obtained by taking the VDS, that means drain to source voltage on x-axis and drain to source current on y-axis for both the transistor, that means enhancement mode as well as depletion mode transistors. So in order to obtain the transfer characteristics, it is necessary to superimpose gate to source voltage whose value is 0 for depletion mode transistor. So it should be superimposed on the family of curves for the enhancement mode device. Now if you look at the graph, we could see that whenever the maximum voltage appears across the enhancement mode device, so it will be minimum voltage across the depletion mode transistor. That means they are going to act in opposite manner. That means whenever we are going to increase the input voltage, that means VGS, gate to source voltage at the pull down transistor. So as soon as it exceeds the threshold voltage of enhancement mode device, the enhancement mode transistor starts conducting. So it comes out of saturation and becomes resistive, and slowly the current across it will be increasing and the voltage across it will be decreasing. So that means whenever the input is low, it is going to produce the output as logic 1, and whenever the input is high, it is going to produce the output as logic 0. So which is nothing but the Nmos inverter operation.